Welcome to clickmyproject.com. This video will lead us to the complete demo of environmental and disaster sensing using cloud computing infrastructure. Let us see the abstract of our process. Problems that may occur in remote monitoring, such as the number of objects to be monitored and how fast, how much data to be transmitted to the data center to be processed properly. This study proposes using the cloud computing infrastructure as processing center in the remote sensing data. We also propose using FTR HTTP method to guarantee the delivery from remote client to server. Building an integrated remote monitoring system will require a better network management between the clients with the manager. To minimize operational expenditure of a network management solution, the network is usually managed from a central location. Let us see the flow of our process. Here there will be a client and he will be sending any sensor data to the cloud. So in cloud we are saving the sensor data in both of the virtual machines in the cloud. In our process we are having only 2 virtual machines and the data is stored in both of the virtual machines. So the network sensor data will be retrieved by the client by sending the location and magnitude to the cloud. So it will be received from the maximum pre-memory VM. If this memory is not available because of any reasons like a network problem, it will be retrieved from the another VM. So here we are including the fault tolerance too. So the data will be retrieved by the client, and after this process we are going to manage the resources in the cloud. So the cloud infrastructure is managed. So here the client give any process, any changed process, any updated process. So this updated process will be stored into the data, stored into the cloud. Before storing into the cloud, we are going to calculate the processing memory computation. This is called the demand of this process, and we are evaluating the maximum pre-memory VM, and this resource will be allocated based on the demand. So based on the demand, the process will be allocated to VM1 or VM2. It depends upon the demand and the maximum pre-memory VM. So after this process, we are going to allocate the dynamic fluctuation. So we are going to handle the dynamic fluctuation in cloud. So for that process, we are going to evaluate the demand of the process, and if the demand exceeds the capacity, we are going to split the process into 2. As we are having 2 virtual machines, we are splitting it into 2. And here the process split is occurring. If the demand greater than capacity, we will split the process. Otherwise, we will allocate the resource based on the demand. We allocate the maximum pre-memory VM. So in this case, for dynamic fluctuations, so we are going to balance the load. Here we are splitting the process into 2 as we are having only 2 virtual machines in the cloud. Here we are creating the cloud environment using a VMware workstation. Okay, so split 1 and 2. For both of the process, we are computing the demand. This is called processing memory. And after computing this, we are evaluating the maximum demand process and minimum demand process. And now we are evaluating the virtual machines in the cloud again. And we are allocating the maximum process into the max capacity VM and minimum demand process into the minimum capacity VM. So after this process, we are evaluating the load balancing. So we'll show you in graph like the load balancing, the initial allocation and final allocation after applying these conditions and techniques, and the CPU utilization and physical free memory utilization will be evaluated and shown in graph. Let us see the execution of our process. Start both virtual machines in the system and then VM1. Click on load and then click send. Open VM2 and click on load, click send. Open the client window in client machine and click on receive capacity. Here the physical free memory and CPU usage for VM1 and VM2 is received. Click on proceed. So now we are going to allocate the sensor data in both virtual machines. So click on data. Here the data will be displayed, and before clicking this button, we need to receive on the VM should be ready to receive the data. Open the receiving window in both virtual machines and click on receive data. This is VM1. Click on receive data. It will be on hold. Open VM2 and click receive. Open client window and click on VM1 allocation. This data will be stored into VM1 and click on VM2 allocation. The data will be stored in VM2. Open the VM window. Click on save button. Here the data will be stored into the database. It shows your data stored. So in virtual machine 1, the data will be stored in the server database. Click OK. Open VM2 and save the data. Here the data is stored. Open client window and click on proceed button. Now the earthquake sensor data will be retrieved from the VM1 or VM2. We have to select the virtual machine. From which virtual machine we are going to retrieve data. So here I am selecting VM2. Click the location. Enter the magnitude and location. Click on submit. Here the information is retrieved from VM2. So for this location and magnitude, this information is retrieved. Click on OK. Click proceed. So here the VM capacity for VM1 and 2, the memory and CPU is displayed here. We are going to handle the dynamic fluctuation in the virtual machines. So click on browse and select any text file. So here the demand of the data, file name is displayed, the demand is displayed here in bytes. So before clicking manage, the virtual machines should be ready. Open VM1 window and click on receive data. Open VM2 and click receive. Open the client window and click on manage button. Here the data will be allocated in VM1. Click on next. So in VM1 the data will be received. We'll show that. In VM1 the data is received here. Open the client window. Now for load balancing, click browse button and select any file. Select the file and click open. So here the file name is displayed and click balance for load balancing. Click OK. Click the balance button. So now the load is balanced. Click OK. So click on share on button and select the split file 1. It will be stored in the same location from where we selected the first file. Here it is splitted and stored. Click the first split. Click open. Here the demand of the splits are displayed. This is the original file demand. And click share to and select the split 2 file. Here the split file 2 and the bytes are displayed. Click proceed. So now before clicking VM load, we need to run the virtual machines. Open VM1 window and click on receive. Open VM2 and click receive. Open the client window and click VM load. Here VM1 has maximum free memory. It shows the message. Click OK. The memory of VM1 and 2 is displayed here. There we clicked on receive button. So click on allocate. Click on allocate button. Now the VM1 has maximum free memory. Split file 1 is allocated in VM2 and split file 2 is allocated in VM1. Click on evaluate. So before evaluation, the split 1 and 2 is stored into VM1 and 2. We'll show that. In VM1, the split file is stored. It is viewed here. Click. Open the client window. Click on memory for memory evaluation. So here the VM1 has the initial memory and final memory, and VM2's initial memory and final memory. So it is utilized less, and now it is utilized more. So likewise VM2 utilization initial and the final utilization of memory. Click on CPU. So likewise the CPU efficiency, the initial usage and final usage, the initial usage of VM2 and final usage of VM2. Now click on initial load. So this is the initial load of VM1 and 2. Click on balance load. This is the balance load. Here the load is balanced now, and we can compare the initial load and final load. So initially VM1 has maximum free memory, it is utilized more, and finally we balance the load by the efficient data retrieval, sensor data retrieval from both of the VMs. Here we utilize the fault tolerance. If a single VM has any problem in data retrieval, from another VM we can retrieve the data, and we handle the data fluctuation and load balancing in cloud infrastructure. Here we achieve the efficient data retrieval and the efficient load balancing by using the CPU and memory attributes of the systems. Thank you. Thanks for watching.